Hello class, welcome back to another section of our intensive calculus course, still on application of differentiation. In this class, we're going to consider L'Hopital's rule 4. This is the fourth rule, which we apply to simplify indeterminate limit forms. This rule is interested in exponential expressions. If I have a function f of x to the power g of x, then I can apply L'Hopital's rule 4, provided my resulting solution, after finding the limit of this function at a certain point, I get 0 to the power 0, yes. Any number to the power 0 is 1, but if you have 0 to the power 0, it's indeterminate. Another example is infinity to the power 0. Infinity is a huge number, but we have a mathematical statement that any number to the power 0 is 1. But infinity, being a huge number, cannot be shrunk into 1 just like that. So we say it's indeterminate. Then finally, 1 to the power infinity is also indeterminate. If you get these expressions after applying limits to a function at this point, then you apply L'Hopital's rule 4. This rule is different from the previous rule in that the previous rule, all that we do is we express the function in quotients, then after we differentiate f prime of x over g prime of x, then after we apply our limits. This rule looks different from the other rules. Kindly watch this video to the end, don't miss any part of the video so that you understand what we are going to do in today's class. If today is your first time visiting this channel, kindly subscribe, turn on the notification button so that you get updated with every new video I post on this channel. So let's go into what you have for this class. So L'Hopital's rule 4, I'm going to take an example so that we use to solve and see how this concept works. So evaluate limits as x approaches 0 from the positive side of x to the power x. I have this function x to the power x and I'm to find the limits as it approaches 0. Basically, this is going to give me 0 to the power 0, which is an indeterminate form, where I have to apply L'Hopital's rule 4 to aid in simplification. What do? You make y to be equal to x to the power x. Yes, that's the first thing you do. When you have an exponential function like this, you try to bring up the exponent down by introducing the log or the natural log function. So applying ln on both sides, I'm going to get ln y is equal to ln x to the power x. So my ln y will be equal to x ln x. You put this as your equation 1. From this, as I've written here, from this expression, I'll say that ln y is equal to ln x to the power x, yes, as I have here. So once I get this, once I get my equation 1 as I put it down like this, the next thing is I'm going to apply limits. I'm going to apply limits to this. So now let's see, what will be my y, or what will be my x to the power x. So see something from this side. If I have ln y equals ln x to the power x, then the base here e, I'll say that e to the power ln y will be equal to my x to the power x. Let's put this equation down. If you have ln y equals ln x to the power x, then you say that e to the power ln y will be equal to x to the power x, right? Yes. Once we get this, the next stuff we're going to do is we are interested in finding the limit of the function x to the power x as s approaches 0 from the positive side. Therefore, we are going to apply limits on this, our final equation. So if you say limits as s approaches 0 plus of x to the power x should be equal to the limits as s approaches 0 from the positive side of e to the power ln y, because there is an equality there. And you know that ln y here is equal to what? X ln x. So we still make our substitution. Ln of x approaches, as x approaches 0 from positive side, e to the power x ln x. Now we arrive at a fairly nice function here. So we know that this x ln x here, we can also apply the limits as it approaches 0 from the L'Hopital's rule 2. So if I have x ln x and I want to apply limits, so remember from the rules of limits, it says if you have a limit of a constant to a power of a function x, then you put a constant down a, then you get limits of the f of x up there. So here e is a constant, so I'm putting it down so that I find the limit of x ln x as x approaches 0. So once again, it will become ln x over 1 over x since it's a product. I'll differentiate the top one to be 1 over x. If you want to understand this well, kindly go back to my previous video so that you watch the L'Hopital's rule 1 to 3. So from here, 1 over x, then here you get negative 1 over x squared, then you get negative x. So here will give us 0. Therefore, our limit as x approaches 0 from the positive side of e to the power x ln x is equal to e to the power 0. And that is giving us what? 1. If the limit of this is equal to 1, there was an equation here that the limit of x to the power x is equal to the limit of e to the power ln y, and it's also equal to the limit of e to the power x ln x. So since this is equal to 1, this will be equal to 1. And finally, the limit as x approaches 0 plus of x to the power x will also be equal to 1. This looks quite messy. Watch this video severally so you understand it well. I'm going to solve more problems in our future tutorial videos. Don't forget to subscribe to this channel, you like and you share as well.